Hello class, today we're going to be learning lesson 3-4 in your textbook, which is titled How to Find and Use Slopes of Lines. And so we've learned about slope in the past, probably the past couple years you've talked about slope. And what I want you to always remember is that slope is really the steepness of a line. So I'm going to write that down, how steep a line is. We know that any line that you draw can be different from another line. It could be going up at a further rate. And so what we're thinking about, I have a little diagram right here, is that on any line I can draw some points. And from one point to another, that's how I'm going to be able to figure out what the slope of that line is, what the steepness is. And we do that by calling slope the letter M. And we calculate the rise over the run. So this means we're going to calculate how far this line rises from one point to another, and then also how far across it runs from side to side. And so you're going to find that really the rise is the change in the y's, and the run is the change in the x's. And how do we find how much something changes? Well, we normally subtract where it ends from where it started from, and so we're going to write y2 minus y1 as the change in the y's, and x2 minus x1 for the change in the x's. And this is based on if my first point, if I label it x1, y1, and my second point x2, y2, if I have these two coordinate points, I can find the slope of this line. And so some things that I want you to think about, which we've talked about in the past, is let's just say that right here, that this is Mount Everest, okay? And that there's different inclines on your whole trip to get up to the flag, so that you could say you reached the top of Mount Everest. So if you're down at the bottom and it's flat, it's not steep at all. The slope is equal to 0. There is no incline going up or down. So whenever you see a flat line or a horizontal line, you want to know and remember that the slope is going to be 0. So then as we're going and we're walking up, this is me walking up Everest, which would never happen in real life, but as you can see, it's going up. And so I'm going to be thinking, oh, this is going to be a positive slope. So I'm going to circle that so that you know that it's positive. So if it's rising from left to right, it's going to have a positive slope. And then I'm getting, oh my goodness, I'm getting to this basically a vertical wall right here to get all the way up to the flag. And you know what? When you see a vertical line, there is no slope. We normally call it undefined. So for right now, I'm just going to put no slope. So let's remember that when you see a vertical line straight up and down, it has no slope. So let's say I finally reach the top. There's me, woohoo, I'm all happy. And then I'm going to go down. It should be very easy for me to go down now, because as you can see, it's actually like I could slide down or I could fall down the rest of the mountain to get to the other side. And this is going to be a negative slope. Okay, so when you see a line and it looks like it's falling from the left to the right, I want you to always remember that that line is going to have a negative slope. And then we get back to flat ground, and again we know that our slope is going to be 0 because it's flat again. So let's just remember that for any of the different things that we look at today for the types of slope that we might see in any of our problems. So as I said, we can use this formula right here to help us calculate the rise or the change of steepness of any line as long as I have 2 points. So our first example is I want you to find the slope of the line that passes through 6, 4 and 8, 2. So I'm going to write my equation. M is equal to y2 minus y1 divided by x2 minus x1. And if it would help you, you can label the 6 as the x1, the y, or the 4 as the y1, and then the 8 as the x2, and the 2 as the y2. I'm just getting tongue-tied. And then I can plug those values in. So I'm going to have 2 minus 4 on the top, that's the change in the y's, and 8 minus 6 on the bottom, that's the change in the x's. This is negative 2 over positive 2, which is negative 1. So this means that my slope for the line passing through those 2 points is negative 1, which means if I was just going to sketch it, I know it's going to be going downward because it's falling, it has a negative slope. We have some postulates in this lesson. So why don't we go ahead and look at these? They're related to specific lines. The first one is called postulate 17, and it's the slope of parallel lines. We know that parallel lines never meet, so there must be something similar with them. In a coordinate plane, 2 non-vertical lines are parallel if and only if they have the same slope. So if I have a diagram here, and let's say I have one line like this, and another parallel line to it. Maybe I should show that they're parallel by them having that extra symbol on them. Then I know that the slope of the red one, we'll just call it M1, and the slope of the second one, we'll call it M2, that those are exactly the same. And that's all that this postulate is telling us. The next postulate is postulate 18, and it's the slope of perpendicular lines. And it says in a coordinate plane, if 2 non-vertical lines are perpendicular, that's going to happen if and only if the product of their slopes is negative 1. So they're not the same, but when you multiply the 2 different slopes, you should get negative 1. So if I have my first line right here, and I have my second line like so, and if I had a symbol that told me that they were perpendicular, then I could say that the slope of M1 times the slope of M2, that's the red one, should be equal to negative 1. This is how you can tell just by looking at slopes if the 2 lines are perpendicular or if they're not. So let's go ahead and do an example right here. This says that line M passes through the point negative 1, 3 and 4, 1. Line T passes through negative 2, 1 and 3, negative 3. Are the 2 lines parallel? This is simple. From our postulate, we know that parallel lines have the exact same slope. So let's just find the slope of them. Let's find the slope of line T. I'll just call it M1. And I'm going to calculate the change in the y's, so 1 minus 3, over the change in the x's, 4 minus negative 1. This is where you really need to be careful. 4 minus negative 1. That's negative 2 on top and 5 on the bottom. And then let's find the slope for line T. I'm going to call it M2. Negative 3 minus negative 1. Be very careful with that. All over 3 minus negative 2. This is the same as, I'm just going to clean it up, negative 3 plus 1 over 3 plus 2 on the bottom. And this also equals negative 2 over 5. So since they have the same slope, I can say, yes, they are parallel. And I'm done. Awesome. One more example for you and then we're done. This time, if line H passes through 3, 0 and 7, 6, I want you to graph the line perpendicular to H that passes through this new point, 2, 5. So if you were going to do this on your own, I would first recommend that you plot those first 2 points and draw line H through them. So the first point is 3, 0, and I also have 7, 6. So my line is going to be just connecting those 2 points. That's what I would say for my first step. Okay. After that, we need to find the slope of this line. Okay. So the slope of line H is going to be the change in the y's over the change in the x's. So 6 minus 0 over 7 minus 3. And I get 6 over 4, which is the same as 3/2 when I simplify it. So I found out what the slope is. This is of line H. If I'm going to find the slope of a line perpendicular to H, I need to find what number, when I multiply it times 3/2, is going to give me -1. Well, it's going to be the opposite, because I already have a positive, so I'm going to have to multiply by a negative number, and the reciprocal of it. So this is the line perpendicular to H, has the slope m is equal to -2/3. So now that I have that, we're going to do about 2 more steps. Let's plot the one point that we know that passes through this perpendicular line. It is 2, 5, so over 2 and up 5. Okay. And now that I have my new slope of this line, I'm going to follow what it says. So the way that I want you to break this up is to think of it like this. This means I'm going to rise either up or down, -2, and then I'm going to run sideways to the right. Okay, so since it's a negative number on top, that means I'm going to go down in the negative direction. So starting at this point, 2, 5, I'm going to go down 2. So I'm going to just go ahead and draw myself a line, and you don't have to do that. And then we're going to go over 3. We're going to run 3. 1, 2, 3. And that's where I'm going to plot my final point, right there. And now that I have those 2 points, I can connect them with my ruler. And I have successfully graphed a line that is perpendicular to line H, and it passes through the point 2, 5. And I'm done. So what I want you to do for homework is I want you to actually just do a little bit of analysis yourself. I want you to graph these 3 lines. You can graph them however you want. And as you have them graphed, I want you to describe what happens with small slopes, like 1/3, and then as they get larger to 2 or to 5, what happens? What can you say as you compare those slopes? And come with any questions you might have to class tomorrow.